Transducers. A transducer is defined as a instrument or a device which converts a physical quantity, that is a non-electrical physical quantity, into an electrical quantity. The non-electrical physical quantities may be pressure, temperature, displacement, light, sound, etc. And that is converted into electrical quantities like voltage, current, or capacitance, etc. The transducer contains two parts. One is the sensing element, or otherwise known as sensor, and the second one is the transduction element. The sensing element is producing a measurable response out of the physical conditions, and the transduction element convert this output from the sensor, the measurable response of the sensor, into an electrical quantity. The transducers are classified into various types. First is analog and digital transducers. And in analog transducer, the output will be continuous in nature, and the examples are thermistor, Lvdt, strain gauge, etc. And in digital, the output is a pulsed one, or otherwise we can tell that it is discrete output is getting. And these are nowadays used along with the digital measuring instruments. The second classification is primary and secondary transducer. In primary transducer, we can see that a direct conversion of physical phenomenon to electrical signal. Example is a thermistor, in which the change in temperature is directly converted into a change in output voltage. But in secondary, we are using steps of conversions. So in that, input signal is first sensed by some detectors or sensors. Then its output, the output of the sensor is converted into electrical form. For example, we can consider the pressure measurement using an Lvdt. We can't directly measure the pressure using an Lvdt. So in that case, we are sensing the pressure using a Bowden tube. So here the Bowden tube is the sensor, and so the pressure is converted into a displacement in Bowden tube. So it is again converted into a non-electrical signal. So the Bowden tube is presenting a displacement. So that displacement is then sensed by Lvdt, and that is converted into electrical signal. So the first phase is sensing, and the second Lvdt is doing the transduction. So here the transducer is working in steps. That's why it is on a secondary transducer. The third classification is transducers and inverse transducers. So the transducer is the same thing, which is converting a physical signal into, or physical quantity into, an electrical quantity. So physical is converted into electrical signal. But in inverse transduction, it is a reverse process. That is, electrical quantity is converted into a physical phenomenon. Then it is the inverse transducers. Next is on the basis of transduction principle used. So the general used principles are resistive type, then inductive type, and capacitive type. In resistive type, we can tell an example of thermistors. Then inductive, we can have Lvdt, etc. In a resistive type, With respect to the change in physical quantity, that is non-electrical quantity, the sensor have got a change in resistance, and thus we will have a change in output voltage or current. And in inductive, the induction, electromagnetic induction is used to measure the change in input quantities. And in capacitive, we are using the capacitance, or a change in capacitance is used to measure the varying pressure physical quantity. And finally, it is active and passive transducers. So the active transducer, the active transducers are which are self-generating type. That means that is producing uh, its own electrical uh, energy, and that is used for getting the output. Examples are photovoltaic type of transducers, where it produces the electricity from light. Then piezoelectric crystals are also used. In that, the change in force is producing an electrical output. And of course, the thermocouples also used as active transducers, in which the change in temperature between two junctions is actually generating the electricity. But this generated electricity or electric signal will be very, very weak. That's why we need amplifiers along with these kind of instruments. On the other hand, the passive type, it requires external power source for energy conversions, because we have to provide either AC current or DC current for functioning of these kind of transducers. And the examples are resistive, capacitive, inductive type of transducers are working with these. Are examples of these passive transducers. Lvdt is coming under these kind of transducers. Thanks for watching.